Greetings, hello, welcome. Uh, so in this video, we'll be looking at be looking at more indices problems. Let me just let's write one down. Okay. So I'll be working with more examples regarding indices. So one is as follows. Say you have open brackets a plus b, everything over 2a minus 2b minus the second term is also a fraction, a minus b divided by 2a plus 2b. Then you have a third term, which is 2b squared, all divided by b squared minus a squared, which is a difference of two squares. And then you still have another bracket, 1 over b minus 1 over a. Okay. The question would be, probably it would state, simplify the given expression. Simplify the expression. Right. Nice. So that'll be the first one. We'll do this one and then we'll do the second one. Let's get started. Okay, to solve this one, we see that we have two brackets. We can't expand the brackets right away. Oh, of course we can. There are two ways to do it. You can expand the brackets right away, or you can just write every term in the brackets as a single fraction, and then you multiply out in the end. So let's get solving. So we'll start with this bracket here. Okay, we'll start with this guy. So let's write all these as a single fraction. Or to do that, I'll start off with this guy. I'll write those two as a single fraction first. Okay, to do that I need the lowest common multiple, in which these denominators, this one and that one, can go without leaving a remainder. So I'll just multiply them with one another. Okay, 2a plus 2b. Alright, so that's our lowest common multiple, our denominator for the two expressions. Now what do we put here on top? What's our numerator? Easy. Okay. Now for our numerator, would ask ourselves a question. Question would be, how many times does this denominator, how many times does it go into this new guy which we found here? How many times how many times is that guy divisible by 2a minus 2b multiplied by 2a plus 2b? So to find out the answer, we work it out in this case. 2a minus 2b multiplied by 2a plus 2b divided by 2a minus 2b. So this tells us that 2a minus 2b goes in the lowest common multiple. It goes in there, 2a plus 2b times. So okay, so that tells me, okay, I'll write the numerator first as it is, a plus b, and I'll multiply by the answer I got. How many times this guy how many times this is divisible by that? The answer we got was just 2a plus 2b, 2a plus 2b, which is just this guy here. Then the next term, and the same story goes for this one. So we carry the sign as it is, minus, then we write the numerator for the next term as it is, a minus b, and then we multiply it by how many times this denominator is divisible with our lowest common multiple, which of course is 2a minus 2b, just to show that 2a minus 2b divided by 2a plus 2b divided by 2a plus 2b. That and that one cancel out, which leaves 2a minus 2b, which is exactly that. So, okay. So it's just multiplying with the denominator that is not of the numerator, 2a minus 2b. Okay. Everything subtracts 2b squared over b squared minus a squared multiplied by 1 over b minus 1 over a. Right. So let's see if we can simplify this. Let's see if we can multiply out the brackets or expand the brackets. Right, a would go a multiplied by 2a. Then after that we'll also multiply it again by 2b. So let's go a multiplied by 2a. That will give me 2a squared. A multiplied by 2b. That will give me, well, positive 2b. That will give me 2ab. The next one would say b multiplied by 2a and b again multiplied by 2b. So b multiplied by 2a, that gives us plus 2ab, multiplied by 2b gives us positive 2b squared, 2b squared, minus this sign as it is. Okay, so minus, say, this bracket, these brackets multiplied by those guys. Let's work it out. Okay, cool. So that will be a multiplied by 2a and a multiplied by minus 2 minus 2b. Right. A multiplied by 2a, that will be 2a squared. A multiplied by 2b, that will be minus 2ab. Okay. And then minus b minus b multiplied by 2a, and again multiplied by minus 2b. Minus b multiplied by 2a, that gives me minus 2ab, multiplied by minus 2b becomes positive because it's minus and minus. Minus and minus gives us positive 2b squared. Alright, nice. Okay, all this over the denominator, 2a minus 2b multiplied by 2a plus 2b. Maybe I should also expand the brackets for the denominators as well. Yeah, probably that's a good idea. Let's get to it. 2a multiplied by 2a, again 2a multiplied by 2b, so that goes to, that will be 4a squared, 4a squared plus 4ab and minus 2b multiplied by 2a, and again multiplied by 2b, minus 2 minus 4 4ab and minus 4b squared. Right, minus, as it is, it's not touched, divided by b squared minus squared 1 over b minus 1 over a. Alright, okay. Alright, let's collect like terms now. Okay, we have 2a, not like terms yet. 2ab, 2ab, 2ab plus 2ab, that's 4ab, so write 2a squared plus 4ab plus 2b squared. Alright, this negative 1 multiplies through by everything inside, by this one, and it will also multiply by that one. So all the terms inside that multiply by the minus 1 in front. Otherwise we are expanding the bracket. Okay, this one and this one like terms, so they add up to minus 4ab. Alright, so minus 2a squared minus 2a squared multiplied by minus 4ab, that becomes plus 4ab minus multiplied by 2b squared becomes minus 2b squared divided by 4ab minus 4ab, so answer is 0 because this is as a positive and this one is a negative. Get 0 here. So the bottom you just have 4a squared minus 4b squared, excuse me. Okay, minus 2b squared over b squared minus a squared. Alright, 1 over b minus 1 over a, as it was. We haven't touched the second bracket yet. Now let's see if we can collect like terms here. Okay, 2a and 2a. If we add that, minus 2a plus positive 2a, that gives us 0. Okay. Gives us 0. Alright, what about here? You have 4ab and we have 4ab, that gives us 8ab. So the other one is 0. So 0 plus 8ab plus 8ab of positive 2ab minus, positive 2b squared minus 2b squared, that is 0. So it's just 8ab over 4a squared minus 4b squared. So it's just 8ab over, you can factor out the 4 if we want from here, over 4a squared minus b squared, right, minus 2b squared divided by b squared minus a squared, everything multiplied by 1 over b minus 1 over a. Right, interesting. So right from here, can do some cancellation. Say, okay, 4 there is 1 time, 4 there is 2 times. As a result, we've got 2ab over a squared minus b squared minus 2b squared divided by b squared minus a squared multiplied by excuse me again, multiplied by 1 over b minus 1 over a. Okay, so let's simplify this further. Write it as a single fraction. Write everything in the brackets as a single fraction. Okay. So to write it as a single fraction, to write it as a single fraction, we look for the lowest common multiple of the denominators. Lowest common multiple of a squared minus b squared and b squared minus a squared. They are almost the same, but okay, interesting. That's okay. So to get the lowest common multiple, just multiply the denominators. A squared minus b squared, b squared minus a squared. Cool. Okay, write down the numerator as it is, 2ab, then multiplied by, you say, how many times does the denominator of the first expression go into the lowest common multiple? So it goes in minus b squared, goes in the second numerator, the second denominator, times. So it's just 2ab multiplied by this. That's what we write here. B squared minus a squared. So this is always the case. Whenever you multiply the denominators, you just multiply the numerator by the denominator of the second expression, and you carry the sign as it is, minus. I brought it here, minus, and then write everything after the sign, 2b squared. Then you multiply by the numerator of the first expression, a squared minus b squared. Right. So that's pretty much everything about that. Now all we have to do is just expand the brackets. Oh wait, let's include this guy here. 1 over a. Right. So now expand the bracket for this, the numerator. To that we'll say 2ab multiplied by everything inside. So everything here would multiply by every term inside the bracket. So first one, 2ab, that becomes 2ab cubed minus 2a cubed b. Yeah, okay. We'll do the same story. Minus 2b squared multiplied by everything in the bracket. It will be minus 2a squared b squared, because a is the first letter in the alphabet. Okay. Minus 2b squared multiplied by minus b squared, that becomes positive 2b to the power 4 divided by, a squared minus b squared minus a squared. These are differences of two squares, but you'll get to see it later on. Alright, and everything multiplied by 1 over b minus 1 over a. Alright, cool. So let's continue. now we need to collect like terms. Collect like terms. Like terms. Okay. I'll start with this guy. Minus 2a cubed b. Okay, there's no other one, so minus 2a cubed b. What's next? Okay, after a cubed, the one that follows is a squared. So write minus 2a squared b squared. The next one is a 2a b cubed. Okay, plus 2ab cubed. It's this one. And the last one, 2b to the fourth power plus 2b to the fourth power. Everything divided by b squared minus a squared all over a squared minus b squared. Everything multiplied by 1 over b minus 1 over a. Okay, we're getting somewhere here. Okay. All right. Let me just get space here. Okay. Alright, it seems I cannot copy. I still need to learn how to use that function. But that's alright. Okay, let's continue. We'll continue. Let's continue. Let me see if I can try and get some more space to write this. Go up. Okay. Okay, so we'll continue from here. Alright. This is what we had down there. Those minus 2a cubed b minus 2a squared b squared plus 2ab cubed plus b to the fourth power, and everything was divided by b squared minus a squared and a squared minus b squared. Okay, cool. And all this was multiplied by 1 over b minus 1 over a. Alright, let's see if we can collect or factorize some terms here. Alright, let's see, look at this one. This one has a squared and b common. Okay, so I'll take out minus 2a squared and b. So that leaves me with just a plus b. A plus b plus b, and here we'll take out wait, something is missing here. 2b, I missed a 2 here. Yes, 2b. So right there we'll take out plus 2b cubed, and that becomes a plus b. Divided by, multiplied by 1 over b minus 1 over a. Okay, now we need to talk about this difference of two squares, as I've been calling it. I'm calling it a difference of two squares because it is a difference of two squares. Let me explain it quickly. B squared minus a squared is the same thing. It can be factored as b plus a and b minus a. If you multiply this, it will give you exactly that. So let's test it out. b times b times minus a becomes b squared minus ab plus ab minus a squared. This one is 0, so we have b squared minus a squared, which is equals to b squared minus a squared. Is exactly what we have there. And the same applies for this one. In this case, it will just be in reverse order. Okay, so we can write this as b plus a and b minus a. That is true for that one. Then we can also write a squared minus b squared as a plus b multiplied by a minus b. Okay. Because it too is a difference of 2 square multiplied by a plus b multiplied by a minus b. Alright. Okay, we'll come to this bracket later. Alright. Let's go. Just rewriting what we have there. So a plus b multiplied by 2b squared minus 2a squared b. Okay. So that is 2b cubed minus 2a squared b multiplied by a plus b all over b plus a b minus a and a plus b, a minus b. Alright, cool. So everything is multiplied by 1 over b minus 1 over a. Alright, cool. We can still factorize this one further. Let's do it down here. Factorize 2 and b. So 2b this becomes b squared minus a squared multiplied by a plus b divided by b plus a multiplied by b minus a multiplied by a plus b multiplied by a minus b, right, multiplied by 1 over b minus 1 over a, right. Okay, b squared minus a squared, this is also a product of 2 squares. Yes it is. Yes it is. b squared minus a squared. Okay, let me rewrite it down. So 2b multiplied by b plus a, b minus a multiplied by a plus b, everything over b plus a multiplied by b minus a multiplied by a plus b multiplied by a minus b, everything multiplied by 1 over b minus 1 over a. Don't lose this one. Okay, right, create some space here to work on. Okay, so since it's multiplication, the multiplication everywhere, there is no Well, everything on top is a single term, the numerator is a single term, and the denominator is a single term. Therefore, we can be able to cancel out like terms. This one and this one cancels out. B minus and B minus cancels out, but cancelling out simply means it's everything is 1, 1, 1, 1, 1. But A plus B and A plus B cancels out. Okay, so that leaves me with 2B over A. Leaves me with this one, that one. Okay, so I have 2B over A minus B multiplied by 1 over B minus 1 over A. Okay, so this is now a single fraction. Good work. Now let's also make this into a single fraction. Now let's simplify this one. Okay, let's do it here. Let's do it here. So that will be 1 over B minus 1 over A. So what is, I need to find lowest common multiple for the two denominators. So just multiply them, A, B, and then write 1 as it is. Write it as it is, multiplied by B, by A, I mean. Some story, carry the sign, minus 1 multiplied by B. So there we have it, A minus B over AB. Okay, so coming to our problem, just finishing off, where there's 1 over B minus 1 over A, replace it with that guy because it's the same thing. A minus B over AB. From here we see that we have like terms, A minus B and A minus B is the same because this is multiplication. So this one and this one cancels out. It's 1. Then we have AB here. This is a B, that's a B, so that B and this B cancels out. And in the end we have 2 over 1 multiplied by 1 over A, which is the same thing as 2 multiplied by 1, that is 2, 1 multiplied by A, that is A. So final answer is 2 over A. Alright, so yes, the final answer to that question is 2 over A. Bingo. 2 over A. So thanks for watching. Please like the video, subscribe, share it with your friend, and I'll do the next one in the following video. Thank you.